In this video, we're going to talk about how to simplify expressions. Now, in order to simplify simple expressions, you need to remember the order of operations. There we go. Okay, order of operations. Lots of us remember this as please excuse my dear Aunt Sally. Some of us remember this as PEMDAS, but this is the general rules when you're trying to make an expression become something basically prettier. Now, you're usually given two different kinds of directions when you're trying to simplify expressions. One says evaluate. Now, what they're going to do is they're going to give you an expression like the one I have here, which is x plus 3xy plus 2y. Then they're going to give you values to plug in for x and plug in for y. Now, all they really want you to do is substitute the numbers that they've given you. So instead of x, you're going to have 4 plus, then this is going to be 3 times 4 times 7 plus 2 times 7. Now what you end up with is a really just nasty looking expression, so we're going to use the order of operations to make sure that it simplifies and looks prettier. Now we don't have any parentheses, we don't have any exponents, so the next thing we're going to do is multiply and divide, and you're going to do that from right to left. So this 3 times the 4 times the 7, you're going to get an 84, and then the 4 is going to hang out for the ride, and then over here you have a 2 times 7, which is going to give you 14. Now the only thing left here is to go ahead and make this nice and pretty, so we end up with 98, 102, which is a much easier expression to take a look at. Right, the next example, number 2, we've got a little more complicated expression. We end up with b squared c minus 2bc plus c squared. And again, we have different values for b and c. So when you substitute, you end up with 6 squared times a 2 minus a 2 times 6 times 2 plus, got a parenthesis there, 2 squared. Now, the first thing you're going to do once you substitute that is you still need your order of operations. Now, first order is going to be your exponent. So you're going to need to turn that the 6 into a 36. Not a 32, a 36. So you get 36 times 2. Now, this is all multiply, but you'll notice that this is just a single term. So you can leave that alone, or because it's only one term, you can turn it into a multiply and just turn it into a negative 24. For this purpose, we're going to leave it as a 2 times 6 times 2. And then the next exponent would become a 4. The next thing you're going to end up doing is you're going to do your multiply and divide. 36 times 2, which is 72. Minus 2 times 6 times 2 plus a 4. Then the last step, you're just going to add 72 minus 34 plus 4 is going to give you a final answer of 52. Now, in the next problem, what we have is directions to simplify. Now, you'll notice that I do have a whole bunch of variables in here, but I don't have anything to plug into them. So what you're going to try to do is basically get rid of the parentheses, get rid of all your like terms in order to just make this a easier expression to take a look at. Now we've got a whole bunch of things going in here. Now if you do your order of operations again, that would be parentheses. Now if you look inside these parentheses, we do have them, but you don't have any like terms, so there's not a whole lot you can do about it. The only thing you can do is actually get rid of the parentheses. And in order to do that, we're going to use the distribution property, which you should be familiar with. If not, you'll need to take a look at a previous video about the distribution property. When you take 1a squared times b, or 5a squared times b, you get 5a squared b minus, and that minus comes from the 2, then you have a 2 times a times b. So that is what you end up with this the second distribution. Now these last two terms, there's no parentheses, so we're not going to do anything. Now we're not going to get rid of this exponent either because I can't get rid of my a. I don't have any number to substitute in for a, so I just have to leave it as an a squared. So that negative 11a squared b plus a 2ab is just going to hang along for the ride, and there's not a whole lot you can do about it. So let's go ahead and write that as step 1, that we did our order of operations. Now step 2, you're going to try to combine anything that's a like term. Now when you're combining a like term, you do need to remember that an a squared is not going to be able to combine with an a. Those are not like terms. All I can do when I'm looking at like terms is I can just look at each term, which is what's separated by the minus signs and the plus signs. Whatever letters are there have to be exactly the same in order for me to combine them together. Now, if you look at this first term, I've got an a squared b, and over here I've got an a squared b. Those are like terms. I can combine those. Now, we have 5 of these things, minus 11 of these things, because you have to remember that negative belongs to the 11. So 5 minus 11 is going to give you a negative 6. And I had negative 6 a squared b's. The next thing you're going to combine is I have 2 ab's here and some ab's over here. So if we combine these like terms, I have a minus 2 and a plus 2. Now, if it was a 2 and a 5, you would just add a 2 and a 5. But since you have a plus and a minus of the same integer, they're basically just going to undo each other. So there's no more ABs. Now you need to see if you can simplify anything else. You won't always be able to do that. If you look here, I've got nothing being added, so the very simplest way I can get all of these letters into an expression would be a negative 6a squared times b. The last example, we're going to look at something that involves a little bit of geometry. Now, you need to write and simplify the perimeter of the shape. Now, all of us need to remember that the perimeter means you need to add all the sides together. So we're just going to kind of go around this shape and write down all of the sides that we have. So we end up with a 6 minus x plus a 2x minus 4 plus an x minus 1 plus an x plus a 3x. That should find the perimeter for us. Now when you count these and you want to find out how many terms they have so that you can combine for like terms, remember terms are separated by plus and minus signs. So we have 1, 2, 3, 4, 5, 6, 7, 8 different terms, and we're looking for things that have exactly the same variable. Now, the first thing we have here is we have a 6, which is a regular old number, no variables. So if we keep going, that negative 4 also has a regular number, the negative 1, and that's the last term that we have that just has numbers. So 6 minus 4 minus 1 is just going to be a positive 1. Next, let's go ahead and look at things that have just regular x's. So we have an x here, a 2x here, an x here, an x here, and an x here. Now, all I was looking for was the same variable. So if we take a minus x minus 4, minus x plus 2 plus 1x plus another 1x plus 3 x's gives me 6 x's. That's all we need to do. Now, in math, you usually won't see the variable term all by itself and your number. Well, the math community pretty much says that all your variables need to come first before your constants. So more likely than not, you're going to see that answer as a 6x plus a 1.